Okay, so if I give you a position function and I ask for when is the particle farthest to the left, what that means is that I am looking to minimize position. Okay? Farthest to the left means minimize position. Farthest to the right would be maximizing position, because left and right are locations. And so the way to go about it would be, what's your primary equation? It would be the position, because that's what I'm trying to maximize or minimize. And then you're going to take the derivative of that position, set it equal to 0. You're going to find critical values. And then you are going to evaluate, and when you evaluate, you go back to the primary. So then you'll have S of the endpoints, and then S of the critical values, and because you're minimizing, you choose the lowest or the least value. So keep this in mind. If I ask you for when is the particle farthest to the left, that's minimizing the position. Now in this scenario here, we have a rancher who has a property and there's a river that runs through it, and he wants to put a corral for his animals, and he's going to use the backside, the river as the backside of the corral. So then he only has to worry about the fencing along these sides here, and he has 200 feet of fencing to work with, and he wants to maximize the area. So we are looking for the dimensions that would do it. What dimensions would maximize the area if you have 200 feet of fencing and this is the layout of the fencing? Well, then the primary equation would be whatever you're trying to maximize or minimize, in this case, area. When you look at the area, x times y, you don't have to worry about the fact that there's two sections. Just think of it as one big triangle. So my area is x times y, but then I have two variables and I would like to just have one variable, and so that's where I need a secondary equation, and it comes from the fact that we have 200 feet of fencing. So when I look at the fencing, that is 3y's plus 1x, that's the length of the fencing, and so that should be 200. And if I solve for x, I get that's 200 minus 3y. So then I can come back to my primary equation and now call it a equals, in place of x, 200 minus 3y times y. So it's actually now a function of y, area as a function of y, and you can distribute and get this. You can also think about the domain now, but because the variable is y, think about the values that y could be. Well, it has to be more than 0. You couldn't have a fencing that doesn't have a side along a fence, a length along the y. So then my domain is going to be more than 0 for y, so parentheses 0, and then the three sides put together cannot take up the entire fencing. So y plus y cannot be 200 because you have to leave some room for x. And so that means that I cannot be 200 over 3. I cannot touch that number. The single y has to be less than that. And then that means that I have no endpoints. My critical value has to be the maximum or the minimum. It has to happen between 0 and 200 over 3. So now we'll take our first derivative to find critical values. So that's 200 minus 6y, and we set that equal to 0. So 200 over 6 is equal to y. This is the critical value, and it's the only critical value. And because we have no endpoints, then this should pretty much be it. But if you wanted to and you had time, you could do a first derivative test, and you would see that it's a relative maximum, And because there are no other critical values, then it's the absolute maximum. So now that I have the y, we plug in and find the x. And so then x would be equal to 200 minus 3 times 200 over 6. And I've done this ahead of time. That's going to come out to 100 feet. So the y, this 200 over 6 is actually, I want to say it's 33.333 feet. And the x is 100 feet. And you can do a quick check. If you take 33.333 and multiply it by 3 of them, you get 100. And then if you add 100 for the x, that's your 200 feet of fencing. And because it was the critical value, the only critical value, then this is your absolute maximum area. So then we would say that the dimensions are 100 feet by 33.333 feet. I'm sorry this one's a rushed video, but just go over the ideas and the concepts. I had a much longer video and I pressed the wrong sequence of buttons here in the app, and it just made a mess of it. So I'm trying to send you something that can still help you out, but it's not doesn't take too long to process. Okay? See you tomorrow.